Hello everyone, myself Dr. Aditi Chatterjee from EC department. So today I will discuss operational amplifier, very basics of operational amplifier, which is commonly known as op-amp. Now the name is amplifier because it amplifies the input signal. If it is DC, at the output we will get amplified DC voltage. If we give input signal as AC signal, we will get amplified AC signal at the output. So if the given input signal is like this, it could be like 1 volt peak to peak, then at the output, depending on the amplified gain, the output will be amplified at the output. The name is operational because it used to perform, using op-amp we can perform different mathematical operations like addition, subtraction, integration and differentiation. That's why it is named as operational amplifier. Now in operational amplifier we have two input terminals. One is inverting input terminal, another one is non-inverting input terminal. The output we will get depending on the input we are giving. We can give input at one terminal and we can ground the other terminal, or we can give input at both the terminals. Now here we have not used any feedback. So gain is given by output voltage by input voltage. As it is, we are not applying any feedback, so we can consider this as open loop gain. That will be equal to V out by V in. Now here in the input we have given two voltages V1 and V2. V1 at the non-inverting terminal and V2 is at the inverting terminal. Now here in the non-inverting terminal is plus and inverting terminal is minus. So that implies if you apply voltage at the non-inverting terminal and if you ground the inverting terminal, the output will be amplified and it will be in the same phase. But if you ground the non-inverting terminal and apply the voltage in the input voltage at the inverting terminal, at the output voltage will be amplified but it will be inverted, or there will be 180-degree phase shift. Now here, if you apply voltage at both the terminals, then the output voltage will be given by gain of the open loop amplifier into V1 minus V2. Okay, so this is the output voltage we get for an open loop amplifier. Apart from that, we used to apply supply voltage plus VCC minus VCC in the operational amplifier in pin number 4 and 7. That we will get to see when we will move into the operational IC-741 pin configuration. So this is the pin configuration of IC-741. Here we have 8 pins. Pin 1 and pin 5 are the offset null. Pin 2 and pin number 3 are for the input. We used to give the input voltages either at pin number 2 or pin number 3, or even we can give voltages at both the input pins. Pin number 6 is the output. We will use to check the output or get the output from pin number 6. 4 and 7 is the minus VCC and plus VCC. 8 remained as no connection or not connected. It is written as NC. Now this pin number 1 and 5 are the offset null. In IC-741 or operational amplifier, if you apply same voltages at both the input terminals, we are supposed to get 0. If we don't get 0, then the IC-741 or the op-amp need to be balanced, because if you want a perfect balanced operational amplifier, if we apply same voltages at the two input terminal, we should get 0. Again, if we don't apply any voltage, then also the output should be 0. If we don't get that, then it needs some need to balance. So that balancing is done by the offset null pin 1 and pin number 5. So this is the pin configuration of IC-741. Now come an important topic, which is characteristics of ideal op-amp. So here we have open loop gain as infinite in case of ideal op-amp. But in practical cases, in practical IC-741 op-amp, we used to have the open loop gain as 10 to the power 5 to 10 to the power 6. Infinite input impedance. In case of ideal op-amp, the input impedance should be infinite. But in case of practical op-amp, we used to have the input impedance as 10 to the power 5 to 10 to the power 6 ohm, or you can say in mega ohm range. Zero output impedance. In case of ideal op-amp, the output impedance is 0. But in case of practical op-amp, we used to get only few ohms. Infinite bandwidth, zero output impedance, zero output offset, and infinite common mode rejection ratio, CMRR. This is a ratio of differential mode gain by common mode gain. So we will discuss this CMRR in details in the upcoming videos. So as per the characteristics of ideal op-amp, that we used to have infinite CMRR or common mode rejection ratio. Thank you.